Okay, here's a test. Okay, I'll talk to you about the test a little bit, just tell you what's on it. The first 4 problems, and then I have 4 questions about each one of them. All right, the first 4 problems are going to be like these down here, and they're going to be worth. Since there's 4 questions, I'm going to ask you about each one of them. What will happen if you increase the pressure, decrease the volume, increase the temperature, add A, add B, add C? All right, since they're going to be like that, 4 questions per 4 problems. That's 16 points. That's a lot of points on a topic that you might think, well, we've been doing all these math problems, but these really tell me whether you understand it or not. They really do. Whether it's going to go forward or reverse when you increase or decrease the pressure, temperature, and volume. That really explains it. These, you kind of get into a rut, and you do them by rote, and you kind of, you'll do them, but you won't necessarily understand them. This really make sure you understand them. The rest of the problems are exactly what you'd expect. There'll be easy ones like this first one, and they'll get progressively harder. I want to be able to have time to go over all of these. I'm not going to have time to be able to do the math for every one of these, just setting them up basically. All right, let's do that. Let's start with the first one. Okay. Now, this is a really easy one. You will get one this simple. There's no ICE to it, no ICE. Okay, very simple. You simply have to plug them in. There are things you'll have to remember. First of all, show me the formula. Kc equals NH3 squared over N2 times H2 what? Cubed. All right, plugging my numbers in. So first of all, show me the formula. Secondly, if I plug those numbers in, I'm wrong. It's a 5-liter container. So NH3 is 0.565 divided by 5. What's that? 0.113. 0.113. You're going to have to hurry up and give me these as I do these in order to have at least some of it set up. That's going to be squared over N2. 0.602. 0.602 times 0.402. 0.402 or 2? 20 cubed. Now, there's a couple of things you can do wrong here. You show me all this work, and you're only going to lose 1 point at this point, okay? Because it has the squared, it has the cube, it has the formula, and you divide it by 5. But on the calculator, I bet you some people have the wrong answer. What did you guys get for KC?
0.286.
Everybody get that?
Yeah.
If you didn't, chances are you didn't square it, divide by this, and divide by that guy cubed. Okay? Either that or put parentheses around them. Because you can't go this divided by that times that. Your calculator doesn't know what you're talking about. All right. Good enough. That would be a nice, easy one like that. Secondly, I can give you one like this. This is very much like the one we did in the lab, the stuff that turned red, the iron thiocyanate. All right? This is an ICE problem, but not in the way you think. It's not in the way we've been working on them for the past week or more. All right? This is an ICE problem because you're told the initial. Now, I'll tell you the mistakes you're going to make here. I'll bet you some people did it. 2.4, you did divide by the size of the container. What's that? 0.480 molar, 0.480 molar. Here's the mistake. 2 possibilities. You put that 0.3 in here as an initial. No. The initials are 0. And secondly, you didn't divide that 0.3 by the size of the container. Okay, people did both of those in the last period. What's 0.3 divided by 5?
0.06.
0.060 or whatever? Okay. Now, basically, you know that's what 2C is, but you got to remember this. How is this guy going to go? It's still an ICE problem because you're told the initials and you're told an equilibrium concentration. All right? Well, you know he's got to go that way because I only have reactants. I don't have any products. So minus x, plus 2x, and x. And plus x, right? That's how they're going to change. They follow the coefficients. At equilibrium, I'll have 0.400 minus x, 0.400 minus x. 80.
It doesn't matter.
Whatever, 0.480. 2x and x. All right. Now, at this point, I know this. This is the important piece of information. I know 2x equals 0.06. The next mistake people made, thinking x was 0.06. What's x? Yeah, 2x equals 0.06, so x equals 0.03. That gets plugged in here, here, and there, and that's your final answers. This is very much like the one we did in the lab, okay? Notice I'm still solving for KC in these first 2 problems. You'll have at least 2 like that. Now, the next one, I'm giving you KC. Oops. I'm giving you KC. And I'm asking you to solve for x. So this is your full-blown quadratic formula solving for x problem. ICE. Okay? Your initial, I already told, oh, same 2 liter, that's an easy one to do. A is 0.2 divided by 2 is 0.100 molar, right?
Yeah.
B is 0.0500 molar, and 0 minus x plus 2x. How do we know which way this guy's going to go? Same reason. Now, the next one we got to worry about which way it's going to go, but this one, got to go that way because I only have reactants, don't have any products. 0.100 minus x, 0.0500 minus x, and 2x are your equilibrium concentrations. Now, at this point, I don't have any other information to figure out what x is. I've got to use my Kc. Okay, it's not like I'm solving for Kc in the previous problem. So here's what you need to show me for work. Kc equals formula C squared over A times B. Right? Plug in my stuff. Kc I'm told is 0.0537 equals C, which was 2x, quantity squared, which is not 2x squared, it's 4x squared. A is 0.100 minus x, and B is 0.0500 minus x. Okay? Plug all those in to your, now this is the, from here on, look, if you've got all this shown, you got most of the points already. Okay? You have to FOIL these, cross multiply, combine like terms, and make your x squared function positive. What do? What is that quadratic equation? What does it look like?
3.95.
It's not negative 3.95. I just said that. You have to FOIL this, cross multiply, and make your square of x squared has to be positive. So is it 3.95? X squared, what?
Plus 0.00806.
X minus what?
0.000269.
And that whole thing equals 0. Now, if you get it to that point, all right, if the mistake is between here, and there will be mistakes between there and there, it's only going to cost you a point or two. All right, you plug this into your calculator, you get 2 values for x. Anybody write both of them down? You just wrote the one that works. Which is the one that works?
007.
00729. By the way, did anybody else get that for the quadratic equation? Okay. All right. That gets plugged back in here. Don't forget to times it by 2. Don't forget to subtract it from that, and those are your 3 answers. Okay. All right. Now, I know we skipped probably the most annoying step, which is going from here down to there. But we did enough of those on the board. You did enough of those in practice in the homework that hopefully you're gotten better at it by now. All right. Now, we're going to get to conceptually probably the hardest one to do. These kind. Now, I'll tell you, it won't necessarily be a volume change. It could be a pressure. I could say it in terms of volume or in pressure, or I could say I added NO2 or I added N2O4 or I added both. Okay? So all of those are possibilities. Let's see how we do every one of them. Same basic idea. We're going to ICE, but I would recommend in this kind of a problem, skipping a little bit of, obviously you're not doing that first. You first have to find the Kc, and you're doing that with the numbers they give you. Now notice this guy does not give you the size of the container. He tells you the molarities, which is great. Saves me a little bit of trouble. Kc is going to equal the products. Again, show me the formula. NO2 over the reactants, N2O4. This guy's squared. I plug in the numbers they give me. NO2s is 0.770 molar over N2O4s, which is, oh no, NO2s is 0.060, wasn't it? Yeah, sorry. 0.0600 molar over 0.770 molar. This guy was squared, right? Is that what you have for your formulas? Most of you probably may have gotten at least this. Probably didn't finish this one. That's why we really need to talk about this. What do you get for your Kc if you did that much? 0.00 what?
468.
468. All right. Is that right? Sound good? Okay. Now that's the easy part. Everybody can get that much. It's like, you know what it's like? It's like doing example number 1 I just did a minute ago. You just told the concentrations. You plug them in. You get Kc. Now here comes the problem. At this point, it says I make some change. Now, that change in this case is the volume is suddenly doubled. Now, you got to use your head. What does that mean? It means I pull back on the plunger. I made the size of the container bigger. Size of the container is larger. All right, what happens to the concentration of the particles? If the size of the container doubled, the concentrations did what? That cut in half. So the new concentrations are not 0.06 and 0.770, but rather 0.03 for the NO2. So this guy's going to be 0.0300 more, and this guy's going to be 0.7 divided by what's that? What's that point? 385 more. Okay. So those are your new initial concentrations because I've made this change. Which way is he going to go? That's where you may have to solve for Q. You would have to solve for Q if I told you I added some amount of both of those guys. Do I need to solve for Q in this case? No, because I pulled back on that plunger and I made the concentration of all the gas. I should have had a little G next to all these. All the gaseous particles have become less. It's going to favor the side with more gas particles. It's going to favor this side. It's going to go forward. Minus X plus 2X. That's a big deal, knowing which way it goes. You might have to solve for Q in this one. By the way, I'll tell you right now, I have the test right here. You will have to solve for Q in one of them. Specifically, I'll say, find the Q for this reaction and tell me if it'll go forward or reverse. That's all I'm going to say. And it'll be a very short problem. Because what is Q? It's the same exact thing as KC. Solve the same way. Just find out if he's bigger or smaller, whether he's going to go forward or reverse. All right. Anyway, 0.385 minus X, 0.0300 plus 2X. You now have to solve this guy, put him into the equation. KC equals, again, I know it's annoying, but you have to write it. The formula again, because I have to note that you knew what to do. KC you found to be 0.00468 equals, your new NO2 is 0.0300 plus 2X. Your N2O4 is 0.385 minus X. And once again, what do you have to do? This guy was squared. I got to square him, square the binomial, or FOIL him, however you want to do it. Cross multiply, combine like terms, get your formula. I don't think, did anybody get to the point of the quadratic equation at this point? Because I know we didn't have a lot of time. What'd you get?
X squared.
Just one X squared?
Yeah.
Oh, okay. X squared?
Plus 1.068X.
All right.
Minus 0.091.
Equals 0. Now, I don't know if that's right, because I don't think enough people had it. Normally I ask it. But if it is, assuming that's right, what's it?
2X.
What's that?
I forgot 2X. Like, up at the top. I
Oh.
just have X there.
Oh, so you don't. So this won't be right there. Okay. Well, either way, from here down to this point is the least important part. Now, I know I have to take some points off, but I also know you're going to make some mistakes, and it's not a big deal. I'm not teaching you algebra. That was 8th grade. All right. I'm trying to teach you chemistry. So, I mean, if you make a mistake there, but you still show me all this work, eventually you'll get an X. Hopefully you'll get an X. And even if it doesn't, say you made a mistake, your X comes out to be crazy. I still want you to plug it back in and show me you knew that's where it had to go. Okay?
If I get 2 negatives, okay?
You can't. If you get 2 negatives, you did something wrong.
I know I did something wrong, but then how do I show that?
Again, I just said, even if you obviously won't have time to redo the problem 100 times so you get it right. You're going to plug the X in, even though you know it's wrong, showing me that's what you would do with it.
Which one do I use then?
Well, I don't. It doesn't really make any difference. You know it's the wrong X either way.
Okay.
So it doesn't make any difference.
I'll still get 10 points.
All right, are we going over the
Now
bottom?
let's go over the
Yeah, this is the important. That's why I wanted you to make sure everybody got to these. Okay, these are worth more points than you would think. All right, and I want to talk about each of these and make sure you explain it. Why do I want to add a table? I do not want to add a table to this slide. What the heck? All right. Yeah, that's right. Here we go. Now you ready? First thing was I increased the temperature. Now, I was shocked to find that everybody got these first 2 wrong. Increasing the temperature. Which way is this guy going to go?
Reverse.
It's going to go reverse. Because there, it's just like saying, if I said I increased C, if I added C, wouldn't you all agree it's going to go reverse?
Right.
Well, it's the same thing. He's on the right-hand side. Now, this one I would expect more problems because it's a convention. Positive delta H's mean it's an endothermic reaction, which means it goes over here. So if I heat this guy up, which way is he going?
Forward.
He's going forward. You have to simply know. Positives mean endo, negatives mean exo. And speaking of exo, this one is not as much of a problem because we should know by now from Chem 1 all the way through kinetics and thermodynamics and now. Exothermic means it's given off. So it's going to be somewhere over here energy, right? So it's going to go reverse. If I've made too much energy, it's going to make that side too heavy. It's going to try to get rid of it. All right. Second one. I said I decreased the pressure. Now, when you decrease the pressure, think of the syringe again. I'm pulling back on the syringe. All right, there's my syringe. I pull back on it. Same number of particles. But now I've got same number of particles, more space. What's it going to try to do? Get the side with more particles to get it back to being even. Which side has more gas particles for number 5? The reverse. So it's going to go that way, right? Number 6? The forward. Number 7? Neither. But what if this guy had said L here, or then which side would it go? Reverse, because this guy would have more. Got to look for the G's. All right, it's only gases. I meant to do that, by the way, just to see if anybody would pick up on that. All right. Okay.
What was the last one? Increase in B. Oh, increase in B.
Oh, yeah, I almost forgot. Yeah. One more, guys. That was the easiest one. Saved it for last. If I add B, obviously going forward. If I add B to this one, it's obviously going reverse. If I add B, it's obviously going forward. Whatever you do to one side, you try to get rid of that stress you applied to the system. Okay? If I removed A, which way is he going to go? Reverse. All right.
All right, I'm a fail.
Yeah.